Our next skill with polynomials is factoring, and the first factoring thing we're going to do with polynomials is factor out greatest common factors. Okay, and it's similar to finding the common factors between two numbers that are just numbers. Okay, so to find a GCF, it is the greatest integer factor of each term, and we're going to put greatest common, times the lowest power of each variable in every term. That is basically what we get up for the greatest common factor. And the best way to do this is for me to do just a whole bunch of examples. So I'm probably going to do 10 to 12 examples and show you my thought process. So first one, 16p to the fourth plus 4p cubed. Step one, find the biggest number that goes into both 16 and 4. The biggest number that's in common between 16 and 4 is 4. Write down the lowest power of each variable in every term. Well, I've got p's in both terms, and the lowest power of p is p cubed. Okay? That's our greatest common factor. Then what I need to do is I need to write the rest of what's left over. And factoring, you should remember, is the reverse of distribution. Okay? So I'm unfactoring. So what I need to do now is, once I find the GCF, then we're going to divide by the GCF. So I need to divide every term by 4p cubed. (16 divided by 4 is 4. P to the fourth divided by p cubed is p. Any number divided by itself is 1. So this would be the factored form of that. Next one, 63 plus 45b. Step one, find the biggest number that goes into both 63 and 45. 9 goes into 63 and 9 goes into 45. The way I know that is I add these digits. 6 plus 3 is 9, divisible by 9. 5 plus 4 is 9, divisible by 9. Or I remember it from my multiplication tables. Then I write down the lowest power of the variable in every term. This doesn't have a variable, so I'm not going to have any variables here. Then I do division. 63 divided by 9 is 7. 45 divided by 9 is 5 with the b. If you want to check your work, use the distributive property and you'll get back to your original problem. Not only can I do it with binomials, I can do it with trinomials. 14x plus 21x squared plus 21x cubed. Step one, find the biggest integer factor that goes into 14, 21, and 21, and that would be 7. Write the lowest power of every variable that appears in every term. I have x's in every term. The lowest power is 1. Then do the division by the GCF. (14 divided by 7 is 2. X divided by x is 1. 21 divided by 7 is 3. X squared divided by x is x. 21 divided by 7 is 3. X cubed divided by x is x squared. Not only can I do it with the 3 terms, but I can also do it with things that have more than one variable. 3xy squared plus 6x squared y plus 9y x cubed y squared. Let's do that one. Step 1, write the greatest common integer factor of each term. Biggest number that goes into 3, 6, and 9 is just a 3. Then I write down the lowest power of every variable that appears in every term. X's appear in every term, and the lowest power of x is to the first power. Y's appear in every term, and the lowest power of y is to the first power. Then I do my division. Three divided by 3 is 0. Is 1. X divided by x is 1. Y squared divided by y is y. 6 divided by 3 is 2. X squared divided by x is x. Y divided by y is 1. 9 divided by 3 is 3. X cubed divided by x is x squared. Y squared divided by y is y. Okay? When you get all done, you can tell you're all done is if you have no variables that appear in every term. Okay? Notice I no longer have p's in every term or b's or x's. Y's are missing here and x's are missing there. And you don't have any common integer factors remaining in your numbers. Okay. Last, I'm going to do 4 more just so that you see some more examples. Notice I say the same words every single time I do these problems, and I do the problems the same way every single time. Okay, you want to come up with a consistent method for doing this. So, next one, 63 x to the 12th minus 35 x to the 6th. The biggest number that goes into both 63 and 35 would be 7. Then I find the lowest power of each variable that appears in every term. That would be x's. And the lowest power of x is x to the 6th. Once I have my greatest common factor, I do division. 63 divided by 7 is 9. X to the 12th over x to the 6th is x to the 6th. Negative 35 divided by 7 is negative 5. X to the 6th over x to the 6th is 1, so I don't have any terms with x's there. Notice again, no common factors between 9 and 5, and no x's appearing in at least one of the terms. Next is going to be 50 p cubed q squared plus 50 p squared q squared minus 20. So step 1 is to find the greatest common factor of each of my coefficients. Biggest number that goes into 50, 50, and negative 20 is 10. Then I write down the lowest power of each variable that appears in every term. P's are missing here, so I'm not going to have any P's. Q's are missing there, so I'm not going to have any Q's. Next step is to do the division. 50 divided by 10 is 5. P cubed q squared. 50 divided by 10 is 5. P squared q squared. Negative 20 divided by 10 is negative 2. Okay? Just because you're factoring out a greatest common factor doesn't necessarily mean you're going to have variables on the outside of your factoring problem. Our next one. This one has 2 possible answers, and I'm going to show you my preferred one when we get done here. Negative 3k cubed plus 15k squared minus 6k. I want to find the biggest number that goes into 3, 15, and 6, and that is 3. And here's something I want you to note. If this is in standard form, and that first term is negative, I want you to bring the negative outside. So I'm going to put a negative right here. I can do the work with a positive 3, and then I have a factor. But I want you to bring the negative outside because that will make the remaining work that you would have to do on some of these problems easier. So that's where the difference can come into play. Next, I write the lowest power of each variable in every term. K appears in every term. The lowest power of k is k to the first. Then I do division. Negative 3 divided by negative 3 is 1. K cubed over k is k squared. 15 divided by negative 3 is negative 5. K squared over k is k. Negative 6 divided by negative 3 is a positive 2. K over k is 1. If you would have just divided by the 3k, you would have had the exact same things in here with the opposite sign. And I will tell you that it's a lot easier for us to continue working with stuff where the first term has a positive sign than it is when the first term has a negative sign. That's why if this first term has a negative, if it's in standard form, always pull that negative out first. So that's how you factor out greatest common factors. Again, practice. Be consistent and come up with some sort of routine that you do it the same way every time to come up with the correct answer.